So today we're going to use and apply properties of isosceles triangle. So there's a little bit of vocabulary in this lesson. The first one is the definition of an isosceles triangle. It's a triangle that has at least two sides congruent. Now what you'll be doing in proofs, once we start getting to those, is this is now a new proof reason. That's the definition of isosceles triangle. And I guess what you really want to pay attention is that it's talking about the two sides being congruent. So here's an example of an isosceles triangle off to the right of your paper. These two sides that are congruent are called the legs. So that's what's pointed at in the picture. The base of an isosceles triangle is the other two sides. So here are your legs, the two sides that are congruent, and then your base is just the other side that's not congruent to the other two. Okay. There's also another part of an isosceles triangle is called the vertex angle. That's the angle that the two legs create. And the base angles are formed by the congruent side and its non-congruent side. So these are called your base angles here. And notice that how I labeled them as congruent. Okay. A corollary is a statement that follows immediately from a theorem. So after a theorem is proven, you can use that theorem to prove others. And a corollary is something that's kind of assumed or kind of is obvious almost from a proven theorem. So the first one is an isosceles triangle theorem. So here's another proof reason that you're going to have to put in your proofs is this two sides congruent, then base angles congruent. So it's kind of, you've seen that arrow before with parallel lines. It's the same meaning. It's like an if-then statement as usual. So if two sides are congruent, then the base angles are. So if I were to have this going on in a triangle, then I could say that these two angles are the same. And the next theorem is the converse of that. So converse is reverse, remember? So notice how now it starts with base angles and ends with sides. That's the converse. They just switched it around. And this is also another proof reason. So this one is saying that if you have your base angles congruent, then the two sides are the same. So I could almost, maybe I'll switch the color. So on the difference, this one is you first start with the two sides. On this one, you start with the two angles, and you conclude the sides are the same. The next theorem is going to be used more with your algebraic problems. So say you have an isosceles triangle. You know it's isosceles because it's a triangle and it's got those two sides marked as congruent. Okay. If this is an angle bisector of that vertex angle, then it forces the base and that bisector you just draw to be perpendicular. So you'll use that with your kind of algebraic problems, and it's the converse of it is true as well. So if you have an isosceles triangle and these lines are perpendicular, then that forces those two angles to be the same. This is a corollary that follows that. If a triangle, actually this corollary follows our isosceles triangle theorem. But if a triangle is equilateral, then the triangle is equiangular. So from this theorem up here, that's where that corollary comes from. Because what they're saying is, like, if these two sides are the same, then these angles are. And then if you were to twist your paper around, if these two sides are the same, then these two angles are. And you twist it around again, if these two sides are the same, then these two angles are. So an equilateral triangle is also equiangular. This corollary follows this theorem here. Or not this one, sorry. This one. the converse. This one is saying if you have base angles congruent, then the two sides are the same. And then if you twist it around, if these two angles are congruent, then these two sides are the same. If these two angles are congruent, then these two sides are the same. So if you notice just from writing all the markings, if a triangle is equiangular, then the triangle is equilateral, so all the sides are the same as well. So quite a bit of vocabulary there. So on the back of your note sheet, we have some algebra problems. Okay, so what you want to pay attention to is a lot of markings on here. So let's solve for x first since it's written first. What you want to do first is highlight at least the triangle that it's in and pay attention to the markings. So it's an isosceles triangle. So by that theorem, if these two sides are the same, then their base angles are. So what I can do is I can actually write 50 degrees there as well. And to figure out x, I use the fact that there's 180 degrees in a triangle. So I'm going to take x plus 50 equals 180 degrees and solve for x. So I'm going to first combine like terms. So 50 and 50 is 100. I'm going to subtract 100. So my x is 80. So that is the value of x. Now for y, I'm going to do the same thing. Highlight the triangle y is in, or outline it is what I'm doing. And pay attention to the markings. Now here is kind of a very similar problem, but your base angles in this one are not a number, but your variable y. So just like how I did for x, I plugged in 50 and 50. In this problem, I'm going to do y and y. And I'm going to set it up the same way I did x, only now I have two variables that that I have in my setup. So the way I'm going to do that is I'm going to take y plus 100, set it equal to 180, because there's 180 degrees in a triangle. I'm going to combine my like terms first. So 1y plus another y is 2y. I'm going to subtract over my 100. And I'm left with 2y equaling 80. Divide by 2, y is 40. Right, this one's fairly tricky. Okay, I'm going to solve for x or for y first. So I'm going to outline this triangle. Notice the markings, and this is very similar to our last problem. So what I'm going to do is I'm going to put y here, because if two sides are the same, then their base angles are, and I'm going to sum all the angles to 180. So I'm going to combine like terms. I'm going to subtract over the 108. So I get 2y equals 72. And then divide by 2. So my y, it is 36. So now I'm going to find x. Now I found y first, because if I look at the triangle that x is in, there's not much information. There's just the x. So what I'm going to do is realize that this is a regular polygon, so all the sides are the same. That forces all the angles to be. So this angle right here is going to be, this whole one, is going to be the same as 108. So to figure out this angle here, what I'm going to do is I'm going to take 108 and subtract out this part here, which is y, which is what we found is 36. So when I subtract that out, I get 72. Okay? And since this is an isosceles triangle, I have that as 72 as well. So to find x, I'm going to do the same thing. I'm going to do 72 plus x equals 180. Add these two together. Subtract. And I'm left with 36. So this one's a little tricky because if I look at x and y, the triangle that it's in, okay, there's no numbers. Okay. So there's a triangle next to it, and I'm going to try to use that to figure out what y is, and you'll see why in a second. We'll see where this 40 is. That's an isosceles triangle. So what I did is I know something about the base angles, so what I'm going to do to find y is use the fact that this is a linear pair. So in order to figure out this angle, I let this be the letter A. I just made up a variable. And since this is an isosceles triangle, this is also A. So I'm going to solve for that degree. I'm going to take A plus 40 equals 180. I'm going to combine like terms, subtract. So we have 2a equaling 140, and then divide to get 70. So this is 70, both of these. Okay. Now to figure out y, what I'm going to do to figure out y is use, like I said, that linear pair. So to figure out y, I'm going to take 180 minus that 70. So I get 110. So here's my 110. Now if I look again, if I kind of twist my head around to find x in this triangle, this is also isosceles because it has those two tick marks. So x is also over there. So I'm going to use x plus 110 equals 180 because I know that all the degrees in a triangle add up to 180. So I'm going to combine like terms. We're going to subtract 110. And then divide by 2. So 35. Great. So notice how the sides are all the angles, I should say, are all the same. Okay. Now think about that. You actually know the angle measures of these then. Let's think of how many degrees are in a triangle. And if they're all the same, all I have to do is divide that by 3. So all of these angles are 60. So why did I do that? Well, I'm going to use the fact that x and 60 make a linear pair. So to figure out x, I did 180 minus 60 to get 120. For y, remember that theorem, if a triangle is equiangular, then it's equilateral. So if it's equilateral, that makes all the sides the same. If one of the sides is 13 inches, so is y. This is using the theorem from the front as well. So notice it's an isosceles triangle. This is an angle bisector. If it's an angle bisector, then the base and that angle bisector are perpendicular. So x is 90. All right, same thing here. We can use the fact if this is equilateral, then it's equiangular. If it's equiangular, that forces all these angles to be 60. That's what we did on that last one. So to figure out x, I know that's a right angle, okay? So x plus 60 is going to add up to 90. So the value of x is 30. To find y, use what you know about right triangles, or about triangles in general. So if that's 30 degrees and I have the box as 90, I'm going to do y plus 30 plus 90 equals 180. So I'm going to combine like terms and then subtract. Now we're going to get into proofs. Okay, this is the same kind of thing we've been doing before. Write what you need to prove last. So triangle ABC is congruent to triangle AED. So we're doing a triangle congruence proof. Okay, so that's the one where I'm doing like the red, green, blue triangles congruent, that pattern. So here I have angle 1 and angle 2 congruent. Okay. So there's red. Now I need something else here. So from that, okay, notice what I want you to see is that this is a part of a large isosceles triangle. And we have the base angles congruent. So if these two angles are congruent, then the two sides are. So I'm going to say AB is congruent to AE because this is your new reason. Base angles congruent, then two sides. Yeah, congruent. Okay. So then I look at, I have AC and AD, and I have BC and DE. Sorry, giving me lots of information. Now the reason the triangles are congruent, you could actually say two different reasons. Here are my two that they're talking about. Now you can either say side, 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 or you could say side, angle, side. Both are true. The reason you had to figure out step 2 is because if you were to cover this up, okay, you'd have angle, side, side, or side, side, angle. If you read that backwards, okay, that's the swear, and mathematicians don't swear. That's what you should write at the top of your paper. Mathematicians don't swear. All right, our final problem, write what you need to prove. Triangle VYW is isosceles. Right, so here we have, oops, XY is congruent to YZ, right? Well, notice we have some sides here of a large isosceles triangle. So what I'm going to do is I'm going to say angle 1 and angle 2 are congruent by, if two sides are congruent, then base angles are. And that's your new reason from the front page. All right, next we have 5 and 6 congruent. Okay, and I didn't even notice, I didn't change colors. We had these ones from before. So sorry, I forgot to change colors on that one. So if I have my 3 congruent parts, because I saw my 3 in a row here, now I can say my triangles are congruent. And I have to write the correct order. So I'm going to say triangle XVY is congruent to triangle. So XVY, I'm going to go ZWY. And by the markings, those are congruent by angle, angle, side. Well, remember from before, what follows immediately after your congruent statement is your CP/CTC. So if your triangles are congruent, then you can say they're parts. But this is a tricky one because you need to pick 5 based on what you need to prove in 6. So they want to prove this triangle in the middle congruent. Or not congruent, isosceles. Well, for an isosceles triangle, I know these sides need to be the same. Well, notice those sides overlap with the triangles you just proved. So those are the one I'm going to set congruent to each other. NWY. My CPCTC. So now, for the reason, this is that new one from the front, we have their isosceles because the sides are the same. That's the definition of an isosceles triangle.